Let's put it all together with example 5. Let's put together repeated linear factors and quadratic factors. Write the partial fraction decomposition of x plus 5 over x squared times x squared plus 1 raised to the square. So we need to remember to include a partial fraction with a constant for each power of x. And then we need to include a partial fraction with a linear numerator for each power of the x squared plus 1. So let's try that out. So we write x plus 5 over the x squared times x squared plus 1. So this is going to be a over x plus b over x squared plus, so that's constants over the linear. Now we do the cx plus d over the x squared plus 1 plus ex plus f over the x squared plus 1 raised to the square. So really it's the same thing, it's just more algebra involved. And so we're going to first multiply by the LCD. So then x plus 5 equals a times x squared plus 1 squared plus b times x squared plus 1 squared plus cx plus d times x squared plus 1 plus ex plus f all times x squared. So now we have to expand everything. So we have x plus 5 here. And then, so let's expand what's in here. So that's going to be x to the 4th plus 2x squared plus 1 plus b times x to the 4th plus 2x squared plus 1 plus, let's multiply this side first. So cx plus d times x to the 4th plus x squared plus ex cubed plus fx squared. So let's continue to simplify. So here this is going to be ax to the 5th plus 2ax cubed plus ax plus bx to the 4th plus 2bx squared plus b plus, and then let's multiply this all the way through. This is cx to the 5th plus cx cubed plus dx to the 4th plus dx squared, and then plus ex cubed plus fx squared. Now let's collect our like terms. So we have our x to the 5th and then cx to the 5th. So this is going to be a plus c x to the 5th. Let's look at our 4th powers, 1, 2 of them. So this is plus b plus d x to the 4th. Then let's look at our cubes, 1, 2, 3 of them, plus 2a plus c plus e x cubed. And then let's look at our x squareds. So 2bx squared, dx squared, and fx squared. So this is 2b plus d plus f x squared. And then we'll look at our x's now. So our x, we have just a single ax, and then we have a b, and that's everything. So plus ax plus b. So there's our polynomial, very long. Now let's write our system. So we have x to the 5th. Now we notice we have no x to the 5th power. So let's write this. This is just going to be a plus c equals the 5th power, which is 0. Then we have the 4th power, b plus d, that also equals 0. Then we have our cubes. Our cubes is 2a plus c plus e equals 0. Then we have our x squareds. We have nothing there still. So 2b plus d plus f equals 0. Then we have our x's. We actually have an x here. So let's write ax, a equals 1, right? The coefficient is 1. Then we have our constant, which is b, and that equals 5. So we know A and we know B, and so we're just going to back substitute to solve for the rest. So let's solve for C. So A is 1 plus C equals 0. So therefore we know that C equals -1. So we know what that is. A, B, C. So we can solve for D. So B is 5 plus D equals 0. So D equals -5. And now let's solve for E. So we can plug it in this equation. 2 times 1 plus -1 plus E equals 0. So 2 minus 1 plus E equals 0. So 1 plus E equals 0, or E equals -1. And then now F, so the last equation. So we have 2 times 5 plus D, which is -5, plus F equals 0. So 10 minus 5 plus F equals 0. 5 plus F equals 0, or F equals -5. So now we're finally almost done. Now we have to write the rest. So our partial fraction decomposition is 1 over x plus 5 over x squared plus c, which is -x plus d minus 5 over the x squared plus 1, plus e, which is -1 x minus 5 over x squared plus 1 squared. And then, of course, you could rewrite that, factor out the negatives. So 1 over x plus 5 over x squared minus x plus 5 over x squared plus 1 minus x plus 5 over x squared plus 1 squared. And there's our answer. All right, so try this example. Write the partial fraction decomposition of this one, 4x minus 8 over x squared times x squared plus 2, all raised to this square. Not too bad. It's just a matter of being very careful, attending to precision, making sure you're distributing correctly, adding and subtracting correctly, and just looking at it very carefully. Here's the work if you did it. So it should be a over x plus b over x squared plus cx plus d over x squared plus 2 plus ex plus f over x squared plus 2, all raised to the square. Then you multiply by the LCD, and after all that, you would get a is 1, b is -2, c is -1, d is 2, and e is -2, and f is 4. Then you plug it in, and here's your partial fraction decomposition. Last, here are just some guidelines for solving the basic equation. So for linear factors, you're going to substitute the zeros of the distinct linear factors into the basic equation. For repeated linear factors, use the coefficients determined in step 1 to rewrite the basic equation. Then substitute other convenient values of x and solve for the remaining coefficients. For quadratic factors, you're going to expand the basic equation, then collect terms according to powers of x. Equate the coefficients of like terms to obtain a system of equations involving the constants a, b, and c, and so forth. Then use a system of linear equations to solve for those variables. The other thing to keep in mind is that for improper rational expressions, you must first divide before applying partial fraction decomposition.